I recently posted a video showing this Danish Krag Jorgensen rifle. I bought it deactivated, the barrel had been cut in half, and the bore had been plugged. I built some jigs, removed the plug barrel, and swapped in a spare barrel that I had. Then it fired perfectly fine. Parts for these rifles are hard to come by, and while I was lucky that I had a spare barrel to put onto this rifle, I don't want to just throw out the barrel that it came with. Like I said, it's plugged from about here to here. Also, it's been cut right here, then somehow spliced back together, though it's slightly misaligned. I don't know of any ways to perfectly align and reconnect these pieces, so this barrel will need to be shortened, at least by this much. But that's not a huge concern. The Danish Krag, being a first-generation smokeless powder rifle, has a very long barrel which measures just under 33 inches. Assuming I can use all of this section right up until the cut, that's 22 1/8 inches. It just so happens that there are two carbine variants of the Danish Krag, the artillery and infantry carbines, both of which have 22-inch barrels. They still have barrel jackets and look just like shortened long rifles. I could use this barrel to build a clone of one of those carbines in the future. I want to take a close look at just what this barrel is filled with. I said in the previous video that it's lead, because that makes sense as an easy way to plug a bore, and it was common to do so on rifles. But now I'm having second thoughts. I can scratch it with this pick, but not as easily as I would expect if it were lead. I need a closer look at the material, and in order to do so, I'll first center punch it. Then I can drill into it. That's about all I need. I can already tell that it's not lead, since it was much tougher. Lead is very soft and gummy to work with. I'll take a look at the chips. They're definitely not lead. And they're not magnetic either. Looking at the color, it looks like these are aluminum. I started this project with the plans of melting the lead out of this barrel. Lead is a very common way to deactivate and plug rifle bores. I honestly hadn't considered the bore to be plugged with anything else. Why this one has been plugged with aluminum is a mystery, just like why it was cut in the first place. I've never heard of anything like this before. If you have any ideas, leave a comment down below. But for now, the show must go on. I still don't want to write this barrel off just yet. I'll attempt to remove the forward portion of it. I'll clamp the barrel in the vise right up to the joint. I can move the forward section, opening up the joint, which tells me that the plug is likely the only thing holding these two pieces together. Since I know that the plug extends into the forward section only about an inch, I'll reverse the barrel in the vise so I can get a better grip on the chamber area. Maybe I can pull them apart. And that did it. What's unexpected is that the plug stayed in the forward section, and that it was only sticking into the larger section by about an inch. So that means that this plug is only about 2 inches long, sticking into each barrel section about an inch. You can see the marks left by the barrel's rifling, and also how it had been hammered into the bore, creating galling. I don't have a use for this anymore. But the main section of the barrel, which I expected to be fully plugged, turns out that it's mostly free. The plug that I saw from the chamber end is short as well. ending only an inch or so past the chamber, and only a bit into the actual rifling past the freebore area. Now that I know what I'm working with, I think I can remove this plug relatively easily. To do so, I have a 1/4-inch steel rod. I cut it about 2 inches long and wrap tape around it at intervals. With any sort of force being applied, this thin rod will easily flex. The tape ensures that it won't do damage to the rifling. I could use this to hammer the plug out, but I'll first try a method with less potential to cause damage. That is, using a heavy-duty clamp to push the rod in the bore. I'll get it set up and use a small piece of hardwood on the end of the rod. From here, I'll just turn the handle. I have to hold it pretty tight, so I got in the way of the camera a bit, but out it comes. I think that the clamp built up pressure until the plug couldn't hold any longer, rather than just pushing it out. Either way, it took a lot less force than I thought it would. I'll take a look at the chamber plug. Looking at the marks left by the rifling, it looks like it was only set into the bore about a 1/4 inch, which is why it came out so easily. Before I take a look at the condition of the bore, I'll clean it out. I'll start with solvent and brushes. Then after spraying in some oil, I'll follow up with patches. Now with a very tight-fitting jag being forced on the bore, I can feel it snag a bit about an inch from the end. Now let's take a look inside the bore. The bore looks really good. Though it looks like there's a ring about an inch in where the jack was getting hung up, but the rest of the way has very strong rifling. Here's a better look at the ring about an inch in from the muzzle. The location of the ring corresponds to where the plug had been driven into the bore. I tried looking at the chamber end for a similar ring, but luckily there's not one there, and the throat looks perfect. I still want to save this barrel, so to remove the ring so that it doesn't affect accuracy, I'll counterbore the muzzle. This will open up the end of the barrel, essentially moving the crown back just over an inch without shortening the barrel. I'll get the barrel set up in the 4-jaw chuck on the lathe. To center it, I'll use this precision test indicator, but I don't want to center the outside of the barrel. Instead, I want the bore centered. A precision pin gauge would be the proper tool here, but the best I have is a size O drill bit, which is a snug fit. That's centered as best as I could get it. It's just over a thou off. I'm not sure what the proper tool for counterboring is. maybe a piloted reamer similar to a chamber reamer, but of course I don't have one of those. I'm going to use a simple drill bit, though it is made from cobalt. It's an 11/32, so just slightly larger than the bore. The only surface that matters here is the end, which will become the barrel's crown. This should leave a decent finish there, though it may chatter going in. Either way, I don't trust a boring bar small enough to fit into the bore to leave a good finish. I'll add some oil, then slowly feed in the drill bit, clearing chips as I go. I went in an inch exactly, which should be enough to remove the ring. The forward barrel section doesn't fit snugly anymore. Without dimensions for the carbine barrel, at least not yet, I don't want to shorten this barrel at all, but I can at least clean up the end. I'll lightly face it. Then I can put on a small chamfer. I'll take a look into the bore again. I can see the step where the counterbore ends. I don't see the ring at all, so the counterbore took care of it. This barrel should shoot nicely now. Unlike the last video, there's no payoff at the end in the form of shooting a part that was deactivated. But one day, I'll be able to piece together enough parts to build a carbine. Until then, I'll file this barrel away. Thanks for watching.